Hello and welcome back again to my channel. Today we are continuing with differentiation. Last time we mentioned that we have several methods of differentiation. The general rule, the first principle, the chain rule, the implicit rule, the product rule. And we dealt with the general rule. We have looked at the first principle. And today we want to look at the chain rule. We want to solve one or two examples under the chain rule. And remember, these things are not isolated. They are intertwined. You can use them in each other, right? So we have a first question here, which says that define dy dx if y is equal to this particular function. And then the second question is to solve for f prime of x, where we have f of x being equal to this. Now, to do this, we are going to use the chain rule. Like I mentioned, they are embedded in each other. So we are applying the general rule inside this one also. So without wasting time, let's get going. So from the chain rule, we are finding dy dx. dy dx is going to be equal to, you can use the substitution method. So dy du multiplying du dx. So it's a chain rule. You deal with one part, then you multiply with the other part. So from our question, we can say that let u to be equal to what is inside the bracket so that we can handle it. So u is equal to 5x cubed minus 3x squared plus 1. Hence, our function is now y equal to u raised to the power 7. This is now the function because we have said that the whole of this, which is this, is equal to u. Hence, we have this. Now, the first thing is to find dy du. We differentiate y with respect to what? U. Differentiate y with respect to u. And we can apply the general rule. The general principle says that if I have y equal to x exponent n, then dy dx will be equal to, you multiply the numerator by the function, that is n times x exponent n, and you subtract 1 from the exponent. You are going to apply the same principle here to solve for dy du. Hence, dy du is going to be equal to 7 times u exponent 7 minus 1. That is 7 u exponent 6. We have found dy du. Now we are going to find du dx. That is, you are differentiating the function u with respect to what? X. That is the second step. U dx is going to be equal to, I'm dealing with this. So you use the same general principle to solve for this. So we have 3 multiplying 5 x exponent 3 minus 1. So we are dealing with this portion. Minus 2 times 3x exponent 2 minus 1 plus 0. The last time I explained that the differential of a constant is 0. Differential of a constant is 0 because we have a constant like this. It means the x component is exponent 0 because any number is always 0 is 1. So in that case, if I am dropping it here, so 0 times 1 makes the whole thing what? 0. So in that the constant is 0. So that portion is gone. Now I have 3 times 5 will give me 15x exponent 2. And also I now take 2 times 3, that will give me 6 exponent 1. And so I have found my du dx. We now join everything together to find what? dy dx, because that is what the question is asking us to find. So, therefore, my dy dx is equal to dy du, which is 7u exponent 6, multiplied by du dx, which is 15x squared minus 6x. Now, remember we have u defined somewhere. We said u is equal to this. So we have to replace the u because it wasn't given in our question. We have chose a variable to represent that particular function. So we can choose any variable at all. So here we chose what? U. Hence, I'm going to substitute it back. We have 7 into bracket 5x exponent 3 minus 3x exponent 2 plus 1. And this is all still multiplied by 15x squared minus 6x. Hence, your dy dx is equal to this exponent 6. Remember, that is 6 here. You have to put it there. Now we have ended up in the question. Simple and short. If the question demands that you expand further, you are going to expand this using the binomial principle, but this is power 6, so you would get a very long time, but I'm making this video short as possible. So this is the first method you are going to use using the chain rule. Looking at it, it means that we differentiate the whole function and multiply by the differential of what is inside the bracket. Okay, so that is what we just did here using what? The chain rule. Now I'm going to clean this and use the other method for us to see. Now, the other way you can solve this, if you don't want to use the dy dx equal to the product of dy du and u dx, what you can do is to follow the chain rule principle still inside here without using what? The substitution. Why? How do we do that? We are finding dy dx, and this must be equal to hold this whole thing, differentiate the entire function. So, and multiply by the differential of what is inside. So to differentiate the whole function, we apply the general rule, right? So multiply this whole function by the exponent. So 7 times what is inside the bracket, exponent 7 minus 1. Remember the general rule. You take y equal to x exponent n. You have dy the x to be equal to n multiply x exponent n minus 1. So the same principle you are going to apply here. Multiply by the numerator, multiply and subtract 1 from the exponent. And that is good. Now multiply by the differential of what is inside the bracket. So differentiate this. So times the differential of that. So differentiation of each item here, you have 3 times 5 times 3 minus 1 so let me clean this portion off. Minus 3 times 2 times 3x exponent 2 minus 1 plus 0, because the differential of a constant is 0, so that portion is 0. Now we go ahead and simplify. So we have 7 bracket 5x squared minus 3x squared. So remember, this is key, not sorry about that, because this is right, we are just maintaining what is inside the bracket. Plus 1, all exponent 6, because we are subtracting 1 from here. And this is multiplied by this whole function. So 3 times 5 is 15 x exponent 2, 3 minus 1. Minus 2 times 3 is 6 exponent 1. And this is what you have for it. So you can use any of these approaches to get your question being solved. Alright? So let's look at the second example. The second example says that you should solve for f prime of x. Now, I mentioned that f prime is the same as dy dx, and this is the same as y prime. So anywhere you see the answer, actually to find the differential of that particular function. So do not be confused. I'm going to clean this and we'll solve this question. The question is giving us this, and we are asked to find f prime of x. Now, f prime of x is equal to, you apply the chain rule, yet still, you differentiate this whole function, multiply by the differential of what is inside the bracket. So if I'm differentiating the whole function, I have 3 multiplied by what is in the bracket, times 3 minus 1. So I'm done with it. Remember, this is still coming from the general rule, right? Multiplied by the differential of what is inside the bracket. So 4 times 3, x is 24 minus 1, plus 0. Differential of the constant is 0. And this is going to be equal to 3 in the bracket 4 plus 2 exponent 2. This minus that is 2. Then multiply by what? 4 times 3 is going to give you 12. X exponent 3. So this is what you have. You can simplify that. 3 times 12 is going to give you 36 x to the power 3. The bracket 3x exponent 4 plus 2 squared. And that is your f prime of what? X. So you can further expand this bracket into 2 and then multiply it before you come out with the final answer. But this is the one you can leave. If it's not in the objective form, you will not correct. So simple as that. Like I mentioned, I don't want to make the video so long. But again, you can use the substitution method to deal with this question. You can say that let u to be equal to 3x exponent 4 plus 2. Because from the chain rule, to find dy dx, which is the same as f prime, it must be equal to the differential of this times the differential of that. So you are differentiating y respect to u and differentiating u respect to x. So this is the first portion. You are differentiating the whole function. Times you are differentiating what is inside. You see? Because the u is what is inside. And that's the same method that we have applied here, simple as that. If you substitute the u here back into the equation, the function becomes f of x to be equal to u exponent 3. Now we can find dy du. So dy du is equal to 3u 3 minus 1. And this is equal to 3u exponent 2, right? Now we can also find the u, the x. We are differentiating the function u with respect to x, and this is going to be equal to 4 times 3 exponent 4 minus 1, and the differential of the constant is what? 0. Which means the u dx is 12x exponent 3. Now we have dy du and then u dx. We can put everything back into our equation. Now we have the y, the x to be equal to dy du, which is this 3u exponent 2 multiplied by the u dx, which is 12x exponent 3. But remember, we said u is equal to this, so we have to substitute because the question wasn't given in the u form. So we quickly substitute that. So we have 3 in the brackets. Where the u? 3x exponent 4 plus 2 all exponent 2. And this is multiplied by 12x exponent 3. So you can multiply this too. So you have 36 in the bracket 3x exponent 4 plus 2 all squared multiplied by x exponent 3. You can bring the x exponent 3 to this side. So you get 36x exponent 3 in bracket 3x exponent 4 plus 2 all squared. And you will still come back to have the same result. So whichever approach you use, you always get the answer right. So if this is your first time of visiting our channel, don't forget to leave a like, subscribe and share so that you can help promote the channel. Thank you and have a blessed time.